Hello everyone, welcome to my YouTube channel Code A to Z, where I share amazing projects, tips, and solutions for developers at all levels, either it is a beginner or it is a professional. So, today I am super excited to talk about a project that contains machine learning, deep learning, and artificial intelligence real world challenges and practical implementations. The project name is Online Payment Fraud Detection System. In today's era, we have seen that on our digital transactions, online payment fraud has become a huge concern for individuals, businesses, and even large organizations. So I decided to build a model that detects fraudulent transactions and protects users from potential threats. Sorry. So this project was a fantastic learning journey for me, and I can't wait to walk you through every step, including all challenges and lessons along with the way, which I have learned. So let's move ahead. First of all, I have to tell one thing. So where did this project idea come from in my mind? Well, I have always been passionate by the potential of machine learning and other artificial intelligence tools to solve real world problems. One day I come across some blogs on platforms like Medium and Kaggle and on Snowd and many other platforms. And one of my favorite is the Medium blogs. So let's come back to our point, where I have read about the online payment fraud detection blogs. These articles explained the growing issues of fraud in digital transactions and inspired me to go in depth. So after researching for a few days, reading documentations and exploring research papers, and many data sets, then I have to decided to work and create a meaningful project model. So at the end, I have decided and started my research and learned a lot of during my whole journey. Now, let me tell you about the tools and technologies I used for this project. First of all, I have to tell you one thing that I have used IEEE CIS fraud detection dataset. By the way, IEEE means that Institute of Electrical and Electronics Engineers, and CIS means Consumer Identity Solutions. This dataset includes features like product CD, card 1 to card 6, like 1, 2, 3, 4, 5, 6, and ADDR1 means address 1 and address 2, and many device type, device info, and or a lot of features. There are some of the files names like train transaction, train identity, test transaction, test identity. Along with that, I have one more file, sample submission. This is a very huge data because of you can see the size of the data set is 1.35 GB. So let's come to our point. Uh, so first of all, we have to decided a proper pathway and learn and crack the this data set, because this data set is fully decoded, as you can see uh, from the description of this uh, competition. In this competition, you will benchmark machine learning models on a challenging large scale data set. The data comes from Vesta real world e-commerce transactions. Vesta basically a bank, which is a corporate bank, uh, which provides the customers to serve the transaction method, without using card, like we have used in our trains like Paytm, Phone Pay, and Google Pay, and many other third party apps. So similar to that, Besta real-world e-commerce transactions dataset is provided in this competition, and you also have the opportunity to create new features to improve your results. So we have to decide which features are useful and which features are not, and if we have to decide to create some other features, so we can start with that. Here one of the line is that this the whole data set is decoded into the some mm, uh, so that decoded because of the security concerns, so that it will not be open to all. So about the features of the dataset and the customer's identity also not open in front of the in front all of the competitors. So let's come back to our point that what tech stacks I have used to prepare this whole model to pre-process and analyze the data. I used Python libraries like Pandas and NumPy. For building and training the model, I worked with powerful machine learning models like Random Forest, XGBoost, as well as neural networks. You can see the documentation which I have write about the payment fraud detection documentation. This is the whole documentation which I have written. You can go through the about of the application, my research and my journey, and model development path and application guide, how to use the application, and the technical resources which I have gone through. So let's come back to our point and see. Finally, I deployed the whole model using the Streamlit, uh, which is an open source Python library for building interactive web apps. Sounds like a lot, right? Don't worry, I will break it all down for you. So here how I approached building the project. So let's come to our first of all dataset. So dataset is a key parameter for building any type of model. Either it is a machine learning, deep learning, natural language processing, or either it is a large language model. So all of these require a data. So first I have to require a data. So I have come through this competition, IEEE CIS found for detection. So here the data set is provided in some of the files like this. Train transaction and identity, the training set, and test transaction identity CSV, the test set. You must predict the edge fraud value for these observations, and sample submission is also provided in the correct format. So like this is the sample submission is open right now, and if we have to see the train transaction dataset, which is you can see the size of that this file is 683 MB, and this dataset contains more than 5 lakh entries in it. So if I have to ask one question to all of you that like in 1 second, how many payment transactions have done in all over the world? This is we can say on an average like 1 crores around 1 crores transaction have been done because in 1 second a lots of transactions are completed. So if we analyze only 5 lakh rows, so this is our just in a few seconds transactions only. But but the data set provided by the organizer of this competition is a lot of broad because it provided different dates of the data set. Like you can see, there are some of the features like transaction ID is fraud, and which is our target variable is fraud, and you can see the zero values are 5 lakh 69,877, and and the uh, fraud transactions are only 20,663 among the 5 lakh transactions. So it is very hard to detect the fraud transaction among all these transactions. So we have to first analyze. This is a very huge deviation towards the non-fraud transactions. So we have to normalize this data set so that it will not overfit the model, and model will not work effectively. So I started by downloading the dataset from Kaggle and exploring it to understand the features in the Google Colab, first of all. And this step was crucial because the dataset had over 400 columns. Right now, you can see 394 columns are right now in this train transactions, and the train identity contains more than around 41 features. So all around more than 400 features are present in the whole dataset, and we have to analyze whole dataset very carefully. In this step two, I have to decide to data pre-processing step, and you can do. Let's come to our notebook where I have draft a whole notebook very smartly, and you can see from here which libraries I have to import it. Like You can see pandas for the data pre-processing and other modeling libraries like sklearn, scikit-learn, and scipy. XGBoost is used because of model building, and hyperopt modules is used to hypertune the model. And other data time and date time modules are also used because to analyze the date time consumers transaction features. So and there are some functions like reduce memory uses, which basically reduce the memory while dealing with the data set. Because as we deal with the 5 lakh rows of the on the whole data set, and there are other files are also present in of the test file. Like see, test file is also of 613 MB. So the whole data set goes more than 10 lakh rows. So this you can see from here. Train dataset contains 5,90,540 and the features are present 393, and in the test dataset the rows are 5 lakh. So all around on an average like 11 lakh rows are present in the whole dataset on an average. So next I have to clean the data and I handle missing values and normalize the numeric features and converted categorical features into the numerical representation, because our model will always would understand only the numerical feature values only, not the categorical values. So pre-processing took a lot of time, and but it was worth it because clean data leads to better models. So like see, there are some of the categorical features like discover, card 4 contains these type of features values, and card 6 contains these type of values, and there are lots of value features. So dealing with the 393 features is a very crucial step for me. But after a long period of time, more than devoting a more than 2 months on this project, then I have to completed the whole project. Then moving to the pre-processing step. So let's move to the pre-processing step. This is just for the know about which features contains how many values, and which are the null values, and how many unique values are present in the data set. Like these all things are provided in this description. So next move to the data set. So say before PCA. So this is the whole data set after merging the test and train data set file. This one test transaction and train transaction. Combining these two files, and then there are see the total rows are 10 lakh 97,000, which is very huge data set to train on a model, and which contains less around 1% of the fraud transactions only. So you can see the how imbalance is the whole data set. So we have to normalize the whole data set also, and provide the model up in a batch processing. So we have done in the further. So first of all, discuss with the pre-processing step. Let's start with the v features, and you can see v features are start from v1 to v339, and there are total of 339 features, which is a lot of features about the v features. So after going through the discussion and in the Kaggle, then I have to analyze what are these V features basically. So then I have to find that there are these features are contains the information about the transaction, from which place this transaction is occurs, and from the money will transfer to that place, and what are the uh, initial steps, and what is the terminals applied on it, what are the third party apps are being used, and a lots of things are encoded, decoded, encoded, so encoded in these features. So you can see among the 339 features, only 339 features are the B features. Among the 394 features, sorry, 339 features are only the V features. Then after reducing the memory of the only the V features, then we have to, you can see, we have reduced it up to the 700 MB. So this will be a very huge, because the memory size is reduced by a lot of like around 13%, so which is very good for workout for our uh, processing steps and in the further steps. So let's move to the next part, and then I've done the PCA on the and analyze which 10 component contains the most important and information of all the whole data set. Then I have chose only those 10 features among the 339 features, and Moving with these 10 features, then the data set will contains only 65 features at now. So let's move to the next part of the model. Then I have done a KNN, which is the uh, modeling, because I have to cluster all those values so that it will provide that the details of which cluster is being used. So that in the behind, I don't know which what is being what I have considered is either a wrong or either it will be goes in a wrong direction. So KNN will provide a graphical visualization of which features are basically belongs to which class and which features are belongs to which cluster. So this graph basically provides that information, and yeah, we can analyze from these graphs like that. There are very spread in this data set in the version 0 and version 1. V0 and V1 after PCA, and yeah, some of the features are very correlated like this, very messy, like V5 and V6 are very close to each other, so it is very hard to classify which cluster is being organized, values will goes gone to which cluster and will not. So let's move to the other features like these. So you can also go on through this the whole documentation, and like yeah, this is the frequency chart graph of the clusters V. And see the one cluster one contains more than 5 lakh features, 5 lakh rows of the whole data set, and which is very huge. So most of the values are belongs to the first cluster. Then moving to the C features and moving to like these M features, ID data set and D features, and after pre-processing all these features, then I have to cluster some of the then I have to create some other features from the whole data set, like sum of all clusters, and then I have decided to split the data set and again from the whole data set df to df train and df test. And because some of the features are not present in the df test, and which are totally null values in the df test, so I have to decided to slice the whole data set and done the feature engineering on the df train data set. So after this address 1 and address 2 features are being used for the further processing. So let's click on this feature, directly move to that feature. So address 1 and address 2 feature. So this is a very large notebook to tell everything in a very short video. It is very hard to compile all the things in a one video. But yeah, you can go through the whole notebook. So sum of cluster after slicing. Then I have to analyze the address one and address two features. Yeah, you can go on through these two features also. I have to show these two features. Why I have decided to go on pre-processing in these two features separately. After reading the discussion from these on the Kaggle, and also gone through the median blogs on the fraud detection dataset, and on the research papers which I have studied during the model building, then I have seen that these two features contains the details about the pin code. Many of the competitor are decided used to are used these two features as a pin code, and there are more features like card 1 to card 6. These contains the details of the card number, which is being used in the uh, transaction. So let's see, click on this. So you can see the card 4 and card 6 contains the values only credit and debit card and Visa and MasterCard. So yeah, you can see the debit card is being used, which is of type Visa. So Visa company is provided that debit card, and card 1, 2, and 3 and 5 contains the information about the card number, which is being hold for that card. So let's move to the email features. So email features, from these features, I have to created some more features like addition of these two values and subtraction of these two values, and first value is matched or not, and first two values are matched or not. So these features are generally created. If you are studied from the natural language processing and many other application, any other modeling, then you have seen that these features are created by us. So if you think that these are very beneficial for us or not, So this is it depends totally on the model's accuracy. So let's move to the email features. In these features, I have seen that some of the sites or links which is being used in the transaction are comes from the different companies like this. Gmail, only Gmail is provided, so gmail.com is not initialized. So I have to decided to give them the core company of that mail. So like that Gmail is comes to the Google. att.net comes from the att, and twc.com comes from the Spectrum, like these, and many others are also like this. Hotmail.es is comes from the Microsoft, and Outlook is also comes from the Microsoft. So these two are similar very much. So to make the uniqueness of the dataset and remove the variation in the dataset, so I have decided the to overcome these and to reduce the spreadness of the information and takes all of them at a one stage. So this mapping is also required. So moving to the next part, after the email features, then I have to go on through the transaction amount which is being used. So yeah, you can see the what type how much the amount variation is there. Around 2.75 lakhs lakh rupees are being used more than 30,000 frequency. So you can see the transaction frequency is more around the 2.75 lakhs. So I have also created some more features from this data set, also from this scope values only, like mean amount around around the ID or around any transaction user. So because I have also analyzed the data set of the joining IDs and transaction. So first I have to display about the transaction ID and uh, told you about this data set also. This dataset basically contains the information about the users, what type of mobile is being used, what type of device are being used, and which type of third-party apps is being used, and what is the user's behavior about the transaction. Like usually it spends a lot of money on money and like see device info, device type, ID 1 to 38 is also encoded because this information is not opened yet because of the security concern. So let's we have to analyze by your own and create own story by your own. So because machine learning is just creating creating your own story. So this is the all over things. So let's move to the model building parts. So comes to the model building, I train multiple models, including random forest, XGBoost, logistic regression, and many models. But at the end, I have decided to come with the neural network because neural network provides me a much more efficient efficiency because I have to created a submission.csv file at the end, which is being submitted in the competition. Then I have scored more than 91%. So I have seen that the model is being analyzed the whole data set very effectively, and XGBoost is the primary core model behind the neural network. So just see this is being used and on the GPU. Then at the end, see these are the hyperparameter tuning on the different values, and at the end I have to predict the values on the provided test set and created a submission.csv file. And finally, once I have built and worked all over the whole model, and I built an interactive app using the Streamlit application. So which is being an open source library of the Python, and this app is allow user to input transaction details and get real-time fraud detections, predictions, and deploying this app was fun, but because it made the project accessible to anyone with an internet connection. So. Uh, so if you want to go on through this application, so just go on through the online payment fraud detector.streamlit.app, and also you can go on through the whole code, and also you can go on through the documentation from this repository, and yeah, you can see the AUC and ROC score for this online payment fraud detection model on the XGBoost is 0.9556, which is very, very good for a machine learning model. So, so at the end, but let's move to the application part and just agree on it. And you can also see the abstract which I have written about the model and disclaimer also, and just provide the details all over it. And some of the information is just on the range, just click on it and you have to provide these details by reading this like range of the transaction amount, a small transaction is this, medium transaction is this, and like this, and more than this. And this is the criteria which is being managed by me, because I have thinking that these are the basically uh, being used during the transaction. So just provide all the information. Let's predict one transaction, like I have used the desktop, and desktop device is window 10 suppose. So just go click on the predict. So model is pre-processing. Pre-processing has started. Pre-processing completed, and now model is on the go way. And now you can see hello. So yeah, here I have not provided the details of our names, and yeah, you can see based on the machine learning model, the risk of this transaction is being fraudulent is low. So the result is very less. So if you want to see the probability of the uh, model, yeah, you can see 1.29% is the clear chances of that this transaction is being fraud, and 98.71% is the transaction of that this transaction is not being fraud. And the threshold which I have used is the zero point 0.5. And what I have also clarified that this model is built on the data set of the 5 lakh records, and out of them 89.54% of the transaction which is basically being the fraud. Out of the 100% of the fraud transaction, 89% are being classified correctly by the model, and the non-fraud transactions, out of the 100%, 88.66% are classified as non-fraud. So the model has the AUC and ROC score of 0.94, which is around 0.94 and 95. So this is very good model for the fraudulent transaction and detection of the fraud in the online transaction. So after the compilation and all over all the things, I have built a documentation, clear and concise documentation. If you see the research and journey which I have gone through, then you can see this Nielsen Bank report and European Central Bank report, and well-known pin codes and advanced techniques, biometric identifications, and I have built a chart, complete scenarios chart like card present chart and card not present chart like this, and layer diagram I also provided, and the data set, transaction data set features I have also provided the whole structure of the model building. So you can see this model development, which are the major problems like class imbalance, because the data set contains a very less amount of the fraud transactions, like around 2% transactions are being fraud and 98% transactions are not fraud. So this is very imbalanced model. So yeah, this is a very basically a binary classification model. So yeah, and there are some more problems, but video goes too much long, so let's compile the whole thing and you can go on through this. And yeah, this is the model flowchart of our model. First I have gone through the input data, then I have done some feature engineering. Yeah, these are becomes messy, but yeah, you can go on through these things like V features are V1 to V139, which I have already discussed. C features, AM features, and many other features. At the end, clean dataset is being merged and training plus after that, splitting the dataset into testing and training, then model building and hyperparameter tuning, and at the end, testing the dataset. And after testing the dataset, then I have to deploy the model on the Streamlit. You can go on through this, and also you can go on through this readme file. So let's come to the end of the video. So yeah, what wait, there is more. I wanted to make this project beginner friendly, so I created a detailed documentation using mkdocs. And this documentation is I have already discussed, and it is being deployed on the GitHub pages. And here is the best part is that I am sharing this journey with you through this video, from researching blogs to building the model, deploying it, and documenting each and everything. This project have been an amazing experience for me. To wrap it up, the online payment fraud detection model is my attempt to solve a real world problem and using machine learning, and I hope this inspire you to explore similar challenges and build your own solutions. If you like this video, make sure to subscribe to Code A to Z YouTube channel, and more exciting for the coding projects, coding tutorials, and insights into the tech world. Thanks for watching. I will see you in the next video.